So today we'll just talk about some high level details or some common things we encounter at HDFS level. We have seen the overall installation, the different files, the config file, the type of settings that you can do, as well as uh, also the process level communication that happens, name node, data node, and the different stuff around that one. We did also practice the HDFS related commands to interact with the file system in a very basic manner. Listing files, seeing their content, creating directories, changing access level, changing replication factors, as well as also some admin level commands to see reports come like push up running framework into or a running process name node into safe mode and come out of it. Those admin level details. From a developer perspective, the JDBC or sorry, the Java based part of how you interact with those particular APIs, that was an example we saw, that how you use the inbuilt Eclipse to write Java based code and configure the same details. Now, some of the common questions that are asked at HDFS level, because it's just a distributed file system, the way we normally interact with the normal file system, this one has a similar advantage or I'll say interaction model that happens. So if you have this thing that if I add a new node to a cluster, that's something we know that you update your slave files. If you are adding it as a slave process, update your slave file, have identical distribution. That's something which we saw at the multi cluster level. And when you start it up, it starts getting or sending the heartbeat to the name node, and that's how the communication done. But the question is that if that data node has a new capacity, suppose all your individual 10 nodes, if we take just that as an example, each of the 10 servers which are currently having a slave configuration, all of them suppose have 10 GB, and you add 100 GB as a 11th node. Now you added this 11th node just because your existing 10 nodes, they were having a high percentage utilization, so they were like very close to their threshold and all. So the expectation that you have is that now since you have added the capacity, it will automatically redistribute the data and it will balance out the overall utilization. So that's where this question comes, that if I add a new data node to the cluster with HDFS, will your HDFS or name node based process, master process and data node slave process, will they start moving the data from existing node to the new node so as to balance the overall data uniformly across all the nodes? The answer to that is no, it will not happen automatically. You will have to but yeah, there is more chance that any new data that you will add to now the distributed file system, that's most likely go into those that the new block which has been allocated. But yeah, it will not automatically start balancing out the data and all. But there are definitely some ways by which you can start doing that. Some trivial ways is that if you know that a specific directory is occupying a good amount of space, some specific set of files in a particular folder, you just copy those files again. Since you are now doing a copy, there is and you are making a new copy, it is almost the default behavior, or the most likely scenario will be that your name node will allocate the new node as the data block node. So those new blocks will get copied there, and then you delete the old file and rename this new file with the same name. So that's kind of a hack around that particular thing. Or other things, as you know, that since the replication guarantee is a key attribute or a key feature which your excuse me, name node or HDFS guarantees, so it makes sure that you will have a replication or factor taken care. So if you disconnect few nodes from your system or your cluster, now name node will come to know that these data members are out. So it will make sure that the data nodes which are stored on those disconnected slaves, it will start making new copies, and most likely your new server will be the eligible candidate to provide the block storage for them. So either you do a temporary interruption of the service or you just block it out. One other way is again, as you can see, that's where the point 2 and 3 is there, but you do have this balance start hyphen balance.sh balancer.sh script there. If you look into your uh, the bin file, that's where balancer.sh file is there, and you can run that. That's actually an explicit command to your name node that to start a rebalancing thing, and as you will assume that requires copying of existing blocks into the new available capacity and deleting some of them so that the overall utilization becomes the same. So you specify or you start this balancer which is threshold. You try to keep the difference as less as possible. So you can see here that bin/start hash hyphen threshold 5, which means that it will try to the maximum difference between the data utilization on these different nodes will be plus minus 5. That's what it's trying to be. When it will run, it will try to do that particular thing. Again, the ideal thing will be 0, which means that all the slave nodes are exactly utilized at the same percentage level, but practically that's a very difficult target to maintain. So you try to close it somewhere between 5 to 10 thing. That should be a good balancing criteria. Also, since it requires a lot of these redundant work which is not actually giving any fruitful value, at least from a user perspective, it's just a housekeeping job which is running. So you try or you should run it into more off-peak timings that are available. So this is something which is available. When this process runs, it will take the current configuration that you have. So all the slave nodes which are known to the name node, this particular process will apply the logic across all the existing directories at that particular uh, point of time which are available on whenever you are running in. So again, when you are running this process and you are simultaneously creating the directories and all also, again, then you will not be for sure be able to guarantee that on all. But again, if you understand the purpose of balancer is to just balance the data. You are not doing or individually doing at individual directory level or file level. As long as the overall utilization is in the range or the threshold that you have provided, that's what the name node will try to do. For those internal details of how it is moving the blocks across different directory structures, whether they are stored on new or all, that will never be visible to you. That's where the recommendation is that always run it somewhere in the overnight or at off-peak timings. Secondary name node, we just wanted to add certain discussion that it's normally misled because of the name. People who come from distributed clustering background, those who have done WebSphere level or any app server or web server level clustering, they have these terms secondary and primary nodes which are configured in either active passive or n+1 type of architecture, wherein if one fails, the other takes the load, and when things are good, they try to balance the load with each other. So it's a load balancing comma failover support. The secondary name node in your Hadoop is having a totally different purpose. It's just the name that is secondary, but it's nowhere close to uh, the typical clustering responsibility that it is. So that's why it is mentioned here. Its only job is to keep merging the edit file level changes into your FS image at regular intervals, and that's where it tries to get the things you did. Saw that through the settings in HDFS, the checkpoint interval and all that can be done. Again, the DFS node and all those individual values you can configure it so as to have multiple copies, and that's something which you can do through comma separated values. It will just write it up, so that will be there. But secondary name node, at least we should be clear that it's not doing the typical responsibility of what a secondary and primary combination does. It has a totally different purpose when it comes to Hadoop. Okay, does the name node stay in safe mode till all under replicated files are fully replicated? So that's another thing that does it wait for all of it, or does it comes out after a specific percentage? This is a percentage value which is available at your in your HDFS-site. You can configure these different parameters which tells it. So it says that the answer is no, it will not wait for all of them to be fully replicated. Even if the minimal replication, which is typically one, if one good copy is available, it will try to start the name node, sorry, the HDFS will come out, your name node will come out of your safe mode, so that you start actively interacting with your file system, and behind the scene it will try to compensate whatever is unreplicated. It will start some background daemon processes to do that parallel activity, but the only point till which it is not allowing you to do an edit is till the time it has made a check that at least one copy is available. So these are the parameters that it says, that DFS replication minimum, you can specify that, as well as also the threshold itself. If it is set to 1, then all of them should be minimally replicated. What it is adding here as the HDFS-default in newer version, it is your HDFS-site.xml file. And as it says that minimum replication does not mean full replication. Even one copy should be good enough. Okay, now when you want to do something like that, how do I get set up a Hadoop node to use multiple volumes? So if you have multiple different disks to be added to the capacity, you can add it corresponding to these two variables. If you guys have looked into the XML file, these two variables will configure. One is datanode.data and one is namenode.name.dir. So whatever the mount points or the folder structure which you specify for datanode.data, they all will add up to the overall volume or the overall capacity which your data node can use to store the blocks. But if you configure the same and whatever you specify across corresponding to namenode.name.dir, it will make sure that that many replicated copies are available. So on all those mount points which are comma separated, semicolon separated, you just if it is for name node, it will multiplicate, or it will make sure that multiple copies of your edit log and FS image will be available. Decommissioning, if you have to remove something out of an existing cluster, this was a value which we will have to, which we saw at least in our HDFS-site, that you write a file, simple file, put your IP address and the port number where your processes are running. If it's like a data node and all, you can specify task tracker or whatever that's running, and then specify the location of that file using this parameter dfs.host.occlude. This parameter again needs to be specified in your HDFS-site.xml. So whatever the file which is pointed against this exclude, so whatever the file that you point against this exclude, that particular file, at runtime your name node will read that particular file, and it will try to take out all the data and clean up that particular node. And again, it will also, when we say that clean up, it will try to first replicate all the blocks which are stored on that particular data node or the slave machine, and then once it has made sure that those blocks have been replicated successfully on some other capacity which is available, it will try to clean up those folders and all. So if you are starting your cluster, then you don't have to type in any command. You just normally start your cluster and make sure that you have specified this variable. But if it's a running cluster and you have to change it, so, and you have to like push this change, so you do that configuration and then you type refresh nodes. Refresh nodes is just a request for your name node to refresh or do a recheck of the configuration files, and that's when it tries to typically load the DFS host exclude once again. You can say that it forces the name node to read it the exclude file and start the decommissioning process. So this is This is what you will call as a clean decommissioning. There is another way around also. Simply disconnect that machine from your cluster. So in that case, again, so you know that Hadoop will automatically recover. It will, because there is a copy which is maintained at the name node level, and that will be taken care. It's just that the files and all that has been created, that you will have to like normally format the same and then clean it up. And again, you have a UI front. So in the UI front, the 530 as well as 560 thing that we have seen, those the ports where these processes run, you can see that whether the decommissioning is still done and all, because it doesn't mean that the moment you put in it's going to remove it. It takes some time, and you will have to keep monitoring to make sure that it has done a clean I'll say decommissioning for those nodes. Wildcard character is just a additional thing that if you want to execute some wildcard characters type of stuff, you can do that. We will use some wildcard character later on when we are doing map reduce to read our files or point to that particular thing. So many times if they are not working on your shell, just put it in quotes. It should be. This is also a very common question that is asked, that can I have multiple files in HDFS use different block sizes? Now we know that the default one is 64 MB or mostly or sometimes 128, depending upon what's best supported by your host operating system. It's 64 in most common cases, but yes, you definitely have this capability to specify your own sizes also. If you guys this is the API which we practice, file system.create, and we did saw that the file system.makedir is what we practice. But if you do and take a look at the create method there, it is basically an overloaded method, which means that you have multiple different the method remains the same, the name will be same, that is create, but you will have multiple different options to invoke it with different parameters. That's the overloading concept. But you do have this block size thing. Please note that this is highly unrecommended architecture. It's not recommended to be used, but at the same time, Hadoop also does not want you to come up with this conclusion that it is not possible. You have to appreciate that Hadoop is designed for large file systems or sizes or files of large size. So it's always best, at least if you want to utilize the full power of Hadoop, it makes sense to have large files and all. But for small files, you will always have challenge that most of the time will it will go. You can always use or programmatically define a less common size, but it's just that now true value of Hadoop will not be available. But again, you will have to go on a case-to-case basis that how much it's helping out, but you can certainly change that. This is also an important thing to understand, what happens when two clients try to write into the same HDFS file. So the question here is that Hadoop supports exclusive writes only. So it means that when one is writing, the other cannot, and each of them has a different data node to write. So it doesn't happen that one block which is getting written are written by two different data nodes. One data node will write to one block at a time only. So you don't have the locking or parallel writing criteria coming in. Each of the data node running on the slaves has a specific boundary where to start and where to end, and that's how it writes those blocks. So you don't go into that synchronization conflicts between like the thread level that we learn it, that you one process take locks, the another wait, when first finishes the locks get handed over and things like that. So that doesn't happen. All the data nodes which are running independently on the slave processes gets a separate block to write, and if there is another request that comes, it will automatically get rejected a parallel thing. So that's the good thing, since the central command is here name node, it will make sure that exclusive writes happens. There are certain scenarios when you would not like or you would like to configure that at least some capacity on each box should always remain, that you should not run out of hard disk space on some of your systems. And also if you always want to maintain certain specific data portion or size reserved, you can specify the values. You have dfs.datanode.du.reserve. This is again anything which starts with dfs, that's a thumb rule, goes in hdfs-site, and you can just configure that this much space will be left unutilized. So the moment only this much space is left, that data node will no longer be eligible to write anything. It can just read and send the data, but nothing will be written on that data node. It will be assumed to be full as per the name node. When you get issues like file could not be replicated to 0 node instead of 1, this means that you are running out of capacity, or the data node communication is going wrong. So you are not having even a single data node to write your data to. So, and that could happen either because you have run out of capacity, or your data node might have got I'll say networkly disconnected. So you might see capacity, but the name node is not able to do an SSH to your data node or transmit a command so that it writes or communicates that this data needs to be written. So whenever you have that gap, that could happen. Even the other reason could be that you do seize the space, but you do have configured just now the above variable. So all of your nodes are reaching out their reserved parameter. So even if you have the data or space available, but you will still get this command. So again, when you get 0 node, this means that it's related to data, and some of these could be an issue. Your security also could be an issue, wherein your name node is not able to access your data node because you changed some certificates on your data node server, or the credential got changed, or some patch was installed which played with some of the stored certificates and corrupted some of them. So anything could go wrong at that level. So you might as well want to look into those possibilities to come at a conclusion that what could be going wrong. Again, one important thing here that we have discussed many times itself is that if you lose name node copy, the typical copy FS image and all, how or what can be done. So I can see that name node has just one FS image and edit log file that it writes to. So if you lose that, it will be difficult for you to come up with that entire cluster itself, because at least in common mode, unless until you go for HDFS federated and those type of architectures which are more complex one and not a default offering, you have to do a good customization, as well as you have to go for some other custom vendors. It's always advisable that make multiple copies of name node. So on top, when you saw that there was a parameter DFS name node name dot dir, this is something where if you specify, you can use these parameter and specify multiple mount points or directory locations to be utilized to write multiple copies of your FS image and edit log. So that's something which you can do, but if you have not taken those precautions and if you lose it, it will be a difficult thing to recover it up. So it's always make good sense, at least for the admin level, that write it up and on a daily basis schedule a job which takes a hard copy backup itself, just the way you do for other critical files. You configure the same to have that type of backup capability. One last thing is that if you see something like this one message coming in, the 32 missing blocks are there, when you run file system check command over the particular stuff, it means that these many blocks does not have even a single copy, and that means that either you have run out of space or the copies got corrupted, like all the places where your individual replicas were. It could be that for one specific block you chose file or like server 5th server 5, server 9 and server 10, and because of some issue all your servers from 5 to 10 got I'll say corrupted. So in that case you lost all the copies. So there is no single way by which you can recover that. So it depends, like, but at least the interpretation of these type of issues should be in that sense. Name node and HDFS level, you will see most of the time these type of errors only coming in. Zero nodes, zero data node founds or under replicated, and all of that should default point to that some capacity either is required, either you have reached the reserve point, or uh, some other access related stuff is going on. And that's when you look into the log files, which will give you an indication that what could be potentially going wrong. This is something which we have seen, that always when you allocate or put any file in HDFS, it will always allocate 64 MB because the default allocation unit is that much. But that doesn't mean that it is going to utilize all. It is 64 MB is the reserved space that it does. So if even if you upload 1 megabyte or even if you upload 63 MB, the block that will get allocated is 64 MB block. So that's the allocation that we have seen also in the visually thing, that our file was in some MB range, but we did get 64 MB allocated. So it does not get consumed, but it does get blocked so that nobody else can write to that particular block itself. So that's an important thing to at least take care. Let me open this for Q&A, guys. Let's see and answer some of the questions that we have at this point of time. Let's put it up.